Okay, today we're going to talk about coterminal angles. What are coterminal angles? They're angles that have their terminal side in the same position. So how could that happen? Well, if you think about your circle, if I draw in, let's say, 120 degrees. Okay? So starts here. There's 90, 30 more is 120. So this is where 120 degrees is. Well, how else could I end up at that same location? Well, there's two ways. I could either go backwards, and then I would have a negative number that would end me up there. Or I could go this way, but go all the way around the circle and end up back there again. It's just like in skateboarding or skiing or whatever, you spin around the circle more than once. Hence where they come up with the names like 900 degrees and 1080 and 540 and 720 and all those other things. All right, so again, you can have two different ways that you find a coterminal angle. You can go around the circle more than once, or you can go the opposite direction around the circle. Now, just because there's two ways to do it does not mean that there's only two coterminal angles. Because what could we do? How could we come up with more than two? Well, we can keep spinning around this circle as many times as we want to. As long as we stop there, we're still getting a coterminal angle to that 120 degrees. All right, so let's talk about calculating coterminal angles. If we're in degrees, then you're just going to add 360 and subtract 360. But if we want to get all the possible angles, we're going to add and subtract 360n, where n is a whole number. And I'll show you what that means in just a little bit when we start doing examples. Why are we adding 360? Because that's a whole circle. If we're in radians, we're going to add and subtract 2 pi. Again, why 2 pi? Because 2 pi in radians is a whole circle. So if we add it, that's going to give us one direction. If we subtract it, that's going to give us another direction. And again, the n being the whole number. What do these n things mean? That just means I'm spinning around the circle. So again, what do the formulas mean? So let's say I start off with my 120 degree angle on the last page. If I spin around the circle backwards, that's 240 degrees, right? 180 plus the 60 more that it takes to get up here, because this is 30. So that's 240 degrees, but I'm going in the negative direction, so negative 240 degrees. Well, how else could I have gotten that without using my brain so much? Well, I just do 120 minus 360, and that's negative 240, the rest of the circle. Then if I want to go this way, positive, around the circle, so I've gone here. Now if I go around the whole circle, what have I actually gone? I've gone 120, which I did at first. Then I went around the whole circle, so plus 360, and that gives me 480 degrees. And I would do the same thing if I was going in radians. All right, so let's do an example. We'll start off calculating one positive and one negative coterminal angle for 30 degrees. So again, I like to draw my picture here at the beginning so I can get my brain around what I'm doing here. So I've gone 30 degrees here. If I want another angle that ends at that same place. So if I'm going to end up with another positive one, the only way to go in the positive direction and end up here is to go all the way around the circle. So I would have 30 plus the whole circle, that's 390 degrees. If I want a negative one, I could just start here and go this way So I've gone almost the whole circle except for those 30 degrees. So without using the formula, what would that be? Well, the whole circle would be 360, but I didn't go 30 of those. So that would be 330, but I went in the negative direction, backwards. So that's a negative 330. If I go back and use my formula, 30 minus 360, that's a negative 330. Now, this question down here, which is going to show up a lot in pre-calculus and in calculus, says calculate all positive and negative coterminal angles for a 30-degree angle. So I start off with 30, my angle that I was given, and I add and subtract 360. That gives me the two I already came up with. But if I put an n behind here, well, what is that going to do? Well, let's say n is 2. 360 times 2 is 720. What does that mean? That means I spun around the circle twice and then went to 30. So I end up at the same place. If I would put a 7 in there, then 7 times 360, that means I spun around the circle 7 times, but I still have that 30. So that's going to give me all the possible angles that will end up at that same location. All right, let's do an example in radians. So calculate a positive and negative coterminal angle for an angle that's 3 pi over 4 radians. All right, so let's draw our picture. If we're in fourths, remember this is 1 pi. So that's the same as 4 over 4 pi, because 4 over 4 is the same as 1. So where would 3 over 4 be? It would be right there in the middle of those. Because again, if this is 1 pi, this is a half a pi, so that's 2 over 4, so 3 over 4 falls right here. Okay, so if I want to find a positive and a negative coterminal angle, so let's start with my positive one. I'm at 3 pi over 4. I went this way to get there. So the only way to go in the positive direction and end up there is to go all the way around the circle. Well, how far is it around the circle? It's 2 pi, but we're in fourths, so that would be 8 pi over 4. So 3 pi over 4 plus 8 pi over 4 is 11 pi over 4. Then when we want to find the negative one, we just subtract the 8 pi over 4, the 2 pi. So 3 minus 8, negative 5 pi over 4. And again, if you can't figure out that 8 pi over 4 in your head, you could write it down as 3 pi over 4 plus 2 pi. But then in order to add those together, you have to have common denominator. So multiply by 4, multiply by 4. You still get that 8 pi over 4. All right, calculating all positive and negative coterminal angles. So we start off with our 3 pi over 4. We add and subtract our 2 pi. But again, that's only going to give us 2 of them. That's only going to give us these 2 that we learned up here. In order to get all of them, we want to be able to spin around the circle more than one time. So we need that n there showing us that we could spin around the circle multiple times. All right, so there's not any you tries tonight. There should be a homework that's going to have you practice this in degrees.